Okay, so we'll just do some test review problems. And this is the second half of chapter 2. Yeah. Lines. Yeah. Okay, so one thing I want to say about the test is you don't want to forget the basics, right? Always on a test, there's some basic problems. So, and that being said, sometimes the basic problems we misinterpret because we've learned a lot about negatives. So, like one basic type of problem is if I just had x plus 7 and I had greater than or equal to a negative 15, just because there's a negative in a problem doesn't mean there's flipping of signs, okay? So what we're really looking at every time we do a solving, so this would be solve and then graph. That's what you should be able to do on the test. And so when we look at a solving, we're always trying to isolate the variable. So there's no coefficient other than that 1 in front of the variable. So we just subtract, we do the opposite operation. So since there's a plus with the 7, we're going to subtract it from both sides. And these cancel, so we get an x greater than or equal to negative 22. And that problem's complete because the coefficient of x was 1. So just a second. One thing you should be able to do is identify if it's a greater than sign, we would just have an open circle. But now it's a greater than or equal to, so there's two parts, the greater than and the equal to. So there's the open circle and the shading. And that would be negative 22. So to show a graph of the picture, that's as detailed as you need. Yep. Oh, it is the other way. After that. Greater than or equal to 20, so that's as detailed as you need to go. Adam.
So if it says solve, it's just the answer?
Yes, this right here is the answer. If it says graph, that's the graphing solution here.
And then what would it say if you wanted us to rate it?
So words I'm going to reserve for when you do the word problems. Answer the word problems in English sentences, and that'll eliminate confusion. So first page of the quiz, the test is just solve and graph. And I actually only have to graph 2 of them because it's time consuming.
Well, it will just say graph like on a second problem.
Yeah, it'll say graph, and it'll put a number line in there for you.
Okay.
Okay, so then another type of problem, similar level of difficulty. Here's where this one gets tricky, is I still see that there's some trouble here when the constant is first and it's positive. So if I wanted you to solve a problem here, and we still have some simple solving, like maybe this is a 20. One thing I'm really noticing, I know you want to isolate that x, and I'm pretty comfortable that everybody knows that they have to move the 6, but what I'm not comfortable with is I know that people don't have 100% comfort of whether or not to add or subtract that 6. So think of this as a positive 6. So you have to subtract it because the opposite would be a negative 6, and think of that as a subtract. So that would bring us to here. So this cancels. Now I have a 2x less than 14. And remember, you're trying to isolate that x. So what do we do?
Well, you divide it by 2.
Right, you divide both sides by 2.
Yeah, but I was wondering if it was 6 minus 2x, would you subtract 6 and then it'd be a negative 2x?
That's what we're going to do next.
Oh.
Perfect question. So this one, though, Matt, is correct. You divide by 2. If it was a solve and a graph, then since it's just a less than, it's just an open circle, and your shading is less than 7, so that's as detailed as your graph needs to go.
I remember the shading one is always the opposite way, where the arrow is always like.
Okay. All right. So let's do Matthew's question. Same, almost exact same problem. But it's a 6 minus a 2x less than 14. So we still have this as a positive. What do you do, Nadeem?
Subtract the 6.
Subtract the 6.
And you're left with negative 2x.
That's right. So you're left with negative 2x, and you have on the right-hand side a 8. Correct. So this is the operation here is multiply. So you do the opposite, but you're dividing by a negative, which remember is a shortcut. We'll talk about why that shortcut works in a minute. So this is x, but when we divide by a negative, we flip the sign, and we get a negative 4. So one thing I'm hearing from you, some of you really want to go the longer route. So you could take that negative 2x less than 8 and go the long way if it makes more sense to you, which would be adding 2x over. This is a 0 over here. And then subtracting the 8 to this side. So this is the reason the shortcut works. Because we have a negative 8 over here now, and a positive 2, we want to isolate that x. Whoops. We want to isolate the x. So we're going to divide by 2 because the opposite of multiply is divide. And that tells us we have x on the right-hand side and negative 4 on the left-hand side. And so when you look at this, the x is with the y part of the inequality, and that's what we have over here when we take the shortcut. So the shortcut's a way of taking a few steps out and replacing moving this to the other side. It just does it quickly. So you can use the long way or the short way for that. Nadeem.
If you do x over 2 minus 3 times 7 is less over 5. Because that's not what we're supposed to do.
Yes. So we'll do, what I like is
Over negative 2.
x over negative 2
Is this number 4?
minus 3
Plus 7.
plus 7, so 0.5. So this is a multi-step. So this is about as hard as, well, one of the harder ones. So what you would do is, I would do this first. Because you have 3 negatives and 7 positives. So that's a 4. But what I like about the problem that you made up is you have a fraction involved and a negative. So there's all kinds of things going on. The question is this a plus between?
Minus.
But it's 3 negatives and 7 positives.
Oh, plus.
So it's a plus 4. So the first step makes sense? Matt?
Yeah. Oh, I was just wondering, I made up a problem too that I was wondering how you would do.
Let's do this one. So it's good to make up problems because it's making you think about how they're structured.
Wait, what would happen if you had 2 fractions?
Let's say 2 fractions. This becomes 2 fractions. So let's finish the problem.
4 over what?
Or how about the fact that you're just trying to isolate x, so we have to undo order of operations. So we're just going to subtract 4. So this is x over negative 2. And then we have a less than, and this is 4 negatives and a positive 1/2.
So, negative 3.5.
So it's negative 3.5. So far, so good?
I mean, it's it would come out to a number.
Well, watch what happens. This is division, right?
Yeah.
So we have to multiply by negative 2.
And negative times negative is positive.
So we're going to multiply here by negative 2.
Which means
switch the sign.
So because we multiplied by a negative, we're switching the sign. And negative 3.5 times negative 2 is a positive 7. Okay? So that's a great test level problem. Okay?
Okay. So mine is 5 times x minus 4 is less than 3x plus
5, number 5 is 5 times x minus 4
is less than 3x plus 4x.
3x plus 4x like that?
Yeah.
What would you do first? See?
So you would add those. You would add the x's with that 7x, and then you do the same thing to the other side. So it would be 5x minus 20.
Yes. So good. What I like about this one is we have distributive property.
And then you go plus 20 to both sides. I mean, no, sorry. You subtract 5 from that one and add 5 from the other one to the other one.
Okay, because this is a positive 5x, so you could think of that as the opposite being negative or subtract 5x. And so we have a negative 20. What I like about this is it brings a negative in, but really the negative doesn't affect the sign at all. Why is that?
Because you're not multiplying and dividing by it.
Yeah, because there's not a negative here, right? That's just a plain old 2. And we're trying to isolate the variable. So when we do that, we're just divided by a positive 2. And so this is x and negative 10. So when we read right to left, we're saying x is greater than negative 10. So rewrite that. X is greater than negative 10. Rewrite that so the variable is stated on the left. That's how we read in our language, left to right. Okay? I'm looking at, let's throw in one more 2-step. But really, what you see here, if we zoom out, the level of difficulty, this is kind of easy, this number 1. Easy, a little harder. A little harder here because you have a sign flip. Little harder here because you have a fraction. And then number 5, distributive property. That's the difficulty. That's the difficult, and the like terms. That's how difficult the test is. It's not more difficult than that. We're staying with this level of difficulty. Where you might be challenged is we should have a 2-step at least on there, right? We have a 2-step here.
Number 5.
So we really just need to focus on maybe adding in some word problems.
Yeah.
Because if you can do those style problems, you're ready for the first part of the test. Okay? So I'm going to stop and record this because not everybody wants to listen to everything, and then I'll do a separate one for word problems.
How long is the test?
It's short. The test is pretty short. It's about 10 problems.
One side, okay?
One side, front and back, but maybe not all the way front and back.